Okay, we can start. Hello everybody. Today we'll see how SpagoBI allows you to perform what-if analytics. Okay, let's start taking a look at the menu. We start with a very short introduction where I present SpagoBI, and then we go deeply into the functionality. We'll have a demo, and finally we discuss the roadmap. Okay, let's start presenting myself. My name is Ghedin Alberto, and I'm a solution architect. My main activities include the definition and development of new functionality of SpagoBI, BI consulting, training, and definition of big data architectures. Okay, but what is SpagoBI? You can read the answer in the slide. SpagoBI is the only entirely open source solution for business intelligence. The license of SpagoBI is Mozilla Public License version 2. So you can do whatever you want with the SpagoBI. You can download it for free without fill any form. You can use it, change it, you can include it in your own solution and sell it. Okay, but what can you do with SpagoBI? If you already tried the last versions of SpagoBI, you know that it allows you to create interactive dashboard, online analysis, network analysis, geospatial, web examples, service BI, dashboard for mobile devices, and much more. You can collect data from various data sources, such as relational databases, NoSQL, files, web services, Java classes, and so on. But with SpagoBI 5, you have new innovative analytical possibilities. The first one is the in-memory cockpit, a new user-friendly self-service BI tool that allows the final user to create complex analysis just using the drag and drop. Then you have 3 new engines that allows the user to interact with data and to get a new type of information. In particular, you can apply algorithms to your data mining, text mining, and so on. And you can do that with the new data mining engine that integrates R. You can predict the business scenarios, and you can do that with the what-if engine that we will see in a few minutes. You can listen from social and make sentiment analysis and campaign evaluation using the SpagoBI social analysis engine. This will be available soon in version 5.1 that will be released the next month. Okay, now you have an idea of SpagoBI, and so let's see the function for the what-if analytics. Here it is. The what-if engine is an extension of our new OLAP client. The user can explore the cube and change the values simulating a scenario. For instance, suppose the user wants to see the impact of an increment of 1% on taxes of the stores in California. Okay, you can do that with this engine, and now we will see how. Please contact me using the chat. Okay, let me take. Okay. So, with the what-if engine, the user can explore the cube and change values simulating a scenario. For instance, suppose the user wants to see the impact of 1% increment of taxes in the revenues of the store in California, or how the closing of a shop in Yucatan can impact on the sales unit in Mexico. Okay, if you have these needs, you can use the what-if engine. In this slide, you can see the user interacting with the data using the meta language. And this is the meta language, okay? With the meta language, the user can produce arithmetic function, as you can see here, but it can also use dimensional members, aliases, and variables. And we will see some example in the next demo. Here, for instance, we have the user use a dimensional member. We have time in 2011. Okay. There are several ways to manage the modification in the cube, and so there are several algorithms to spread the modification, and we'll discuss about that in a few minutes. The engine provides the mechanism of versioning. So when the user is satisfied by its modification, it can save the changes in a new version. In this slide, you can see the process of the what if. Okay, here you can see this round. Generally, in fact, it's an interactive process that involves more than one actor. Suppose the area manager works on the data, create a scenario, and then the general manager explores this proposal and asks for changes, and so the process starts again. Okay? Now, let's take a look at the main feature in detail, and then we'll take a look at the engine. Okay? First of all, there are two levers for the computation. One in memory and one into the data source. Why? Actually, as you can imagine, if you have a huge cube, it's very costly to apply the modification in your data. So when a user changes a value, the engine applies the modification in memory and only in a small portion of the cube. So the user interface responds immediately. Okay? At a certain point of the simulation, the user saves the changes, and only at that moment the engine writes back the data into the DB. Of course, it doesn't modify the tables of the data warehouse, but it works in a docked structures. In the demo, we see that the user interface is very simple. We have spent a good amount of time in making it easy to reach the most important functionalities. Algorithms. Okay. Version 5 provides the proportional algorithm that spreads changes proportionally to the children. Let me make an example. Suppose we have only a dimension and a measure. The dimension is country, for instance, and the measure is store sales. We can represent the data like a tree, like we see here. Now suppose I'm a businessman and I want to see what happens if in the user I double the amount of suppose, okay, this is the tree, okay, and here I can see all the data. Here I can see the data for the store sales for the United States, here for Mexico, here for Canada, okay. Now suppose I want to double all the store sales for all countries, and then I want to see how this change impact on the United States. Okay, it's a very silly, it's a very silly example, but it will clarify the algorithm. Okay. Here I see the value double, so here I have 10,000, and I see that also the values of the children will be double. Okay. Here I have 10,000, here I have 6,000, 1,000, 3,000. In the previous version, before I applied the algorithm, I had 3,000, and now I have 6,000. So also the values of the children have been doubled. Okay, it's very simple. So the algorithm is very simple. I double the value, and also all the children will be doubled. Okay, so any change will be, every time I change a value, the engine calculates the proportion and then apply that proportion to all the children. From version 5.1, there is another built-in algorithm that spreads the value proportionally to the number of leaves. Okay. Here we have an example. Suppose the last lever, this lever, the last one, contains the fact, okay, of the cube. Now suppose I set the value for the root like 12,000, okay. The algorithm counts the number of leaves, okay, the number of the leaves of the subtree that start from the edited cell, and then it distributes the value on the leaves, okay. In fact, here I have 1, 2, 3, 4, 5, and 6 leaves, okay. I set the value 12,000, so I divide 12,000 by 6, and the result is 2,000. So every leaf take 2,000 as value. Okay. Of course, all the aggregation. Of course, the value of the leaf will be aggregated, and so this is the result of the modification. So, two algorithms. One consider the number of leaves. This one. Okay. And so, if we take every leaf will have the same value. The other algorithm consider the proportion between the edited cell and all the children. Okay. Let me check if there is some question. Okay. Okay. So at this moment we have these two algorithms, but we are already working in other two. The algorithms are a very good point of extension because you can develop your own algorithm and deploy it in SpagoBI. It's very simple because you just have to implement a Java class that contains the logic. And then you have just to deploy this class in your server, in your SpagoBI server, and then you can use this, your new algorithm. Now we can try a demo. So let me take SpagoBI. Okay, maybe I think it's better if I refresh. Okay, this is SpagoBI. Let me open a what if document. Maybe it's better if I zoom a little bit. Okay. So this is the interface, the user interface. Okay. As you can see, it's very simple. Here you have the cube. Here you have the dimensions, and here you have the filters. Then you have the toolbar. Okay. You can interact with the view very simply using the drag and drop. For instance, suppose I want to have the customers on the rows. I just have to take the customer from the filters and put it in the rows. Okay. We will see this later. Okay. Now suppose I want to have the customer like as the first dimension in the rows. I just have to swap the two dimensions, so you have customer and product. So as you can see, there is no cube configuration button. The user just have to interact with the graphical user interface. Okay. Now suppose you want to set a filter. Okay, I just have to click on the funnel and select a value, suppose Canada West. Okay. So here I have the data only for Canada, of course. Let me remove the filter. You can also perform a dicing operation, so select some part of the cube, and you can simply click here and select what you want to see. Suppose data only for Canada. Here we are. Let me. Okay, so as you can see, it's very simple. You just have to click here or there and apply your operation. As you can see here, for customers we have another icon. This is because the dimension customers contains more than one hierarchy. If you want to change it, you just have to go over the icon and select the hierarchy. Suppose I select I keep customers, so I can see that this is the hierarchy. I have all customers. I have the state. I have the cities. So this is the hierarchy for customers. This hierarchy, I can change the hierarchy so I can see the differences. I select short, so I can see that for Canada I have only the city. So I have two hierarchy for the same dimension. It's very simple to swap between hierarchy here. The toolbars offers you all the most common functionality for an OLAP. So we have different type of drills. Now I have selected position, that is the most common one. So if I click on drink, I see the data from drink. Let me change so we can see also the remember. With remember, the remember explodes all the occurrences of the same dimensional member. For example, if I click on drink, I see that I explode the drink for all customers, but also for Canada and also for Mexico and United States. Finally, we have the drill replace that replace the visualization, showing only the portion of the cube I have selected. For instance, I click on food. Okay, and I see only food. Okay, I can go back. And so those are the available drill functionality we have now. Then we have this. We will see this button later, but now we can take a look on these buttons that are the most common ones. So if I click on show parents, I can see the parents. If I click on hide spans, I can see all the spans. Okay, so it's easier to read. I have the button for hide the row and the empty columns, and I have the button for refresh the model. So as you can see, it's a complete solution for the online analysis. This is pretty good because in the previous version we had JPivot and JPalo, and JPivot was very strong, was very good. You can use the profile, the behavioral model, but it wasn't very easy to use. It wasn't very it hasn't a very user-friendly interface. But now with this solution, we have a strong OLAP client, and it's strong, but it's also pretty, I think. Okay. Now we have saw the OLAP. We have seen the OLAP. Now let's take a look at the what if functionalities. The first thing you have to do if you want to perform a what if functionality is to lock the model. So here I have the button. The model now is already locked. Now, okay, so here it's unlocked, so the user can change the cube, and always you have to lock the model, because at this moment only one user can change the values of the cube. Okay. Now, let me think about an assumption. Suppose I know that the taxes of a certain region in Mexico will be increased of 1%, and I want to see how this impacts in my total sales. Okay. So what I can do is suppose say, okay, I click on the measure, so store sales, and I can say, okay, I suppose that let's do that for, I don't know, let me explode the cube. Let me close the product. So I can have all the products. Okay, good. So I can say, okay, suppose in Yucatan, okay, I will have an increase of taxes of 1%. Okay, I can say, okay, I want to add 1%, okay, in this measure, and that's it. Okay, the change is very small, and so I cannot see it, but I can do something like that. Suppose I want to double the value, so it's easier to see the change. Okay, good. So just clicking on the cell and editing the cells, I can have I can create my assumption, I can create my scenario, and so changing this value, I can see that also the aggregate value is changed, and of course this modification have an impact also in the children. If I explode Merida, okay, it's very hard to make to calculate the value, but I can ensure that that it's the total value of the children. Okay, so with this meta language, I can do a lot of things. Here you have seen that I've changed a value. I use the percent value, but I can also connect me to another dimensional value. Suppose I can write here something like the dimension and the value of okay, it should be okay. Here we are. I set that the value of this cell is the same of our brother cells like Sinaloa. I can say also, I can want to say, okay, I want that the value of Guerrero is the same of DF. Ten times the value of customer DF. Okay. So with the meta language, I can use arithmetical function. I can use dimensional members, but I can also use variables, and I can also use alias. What is a variable? Okay, I can say I know that the taxes of my country is 20%. I can create a variable in the template of the document and the value of this variable is 20%. And so when I edit a value, I can say, okay, the value of this cell is the value of another cell plus the taxes. Instead of write 20%, I can just write tax. Okay. I can create also aliases. For instance, if I use very frequently the dimensional member product.drink.dairy, and I don't want to write it every time, I can create an alias called dairy and use this alias in the formulas. Okay. At this moment, you can edit the values only in the cube. So you have to click in a cell and write the formula. But we are already working in a wizard that should be released in the next version. But I still think that the easier and the faster way to edit a cell is directly in the cube, because I think that everyone here is already used Excel or Open Office, and is very used to set values of cell. Okay, so I think it's the faster way. This is still be the faster way. Okay. At this point, we have made some changes. So we have created a scenario, and now I can save these changes, because of course I made these changes, and tomorrow I want to see this. I still want to see these changes. I don't want to lose them, of course. So I can click the button save, and so these changes will be saved in this version, or I can create a new version. Now I just click on save. Of course, this operation can take some time because it will persist the changes into the DB. So now, if I shut down the survey, I can do whatever I want, but the data is persisted into the DB. Okay. Now, suppose I want to flatten the store sales of drink for all the shops. Okay, and I want. Let me do that. Okay, so let me open drinks. So all products, I want to say, so select only drink and food, and let me close also customers. And what I want to do now is just flatten all the values of the shop. So the shop now are the leaves, and what I should do is is to select the second algorithm we saw before, so the one that the equal partition on leaves. So I change algorithm, and then I set the value. For instance, I want to write I don't know. Okay. In this way, all the leaves will have the same value. Okay. And so, as you see, if I want to make a modification, I just have to select the algorithm. Okay. And then edit the value, edit the cell, and the algorithm will be propagated in all the cube. Okay. Firstly in memory, then when you click save, it will be persisted into DB. Now I can say, okay, I've created a new. I edited the value of the value of the cube, and I want to save this modification in a new version. Suppose I want to call it version 3, and I want to say, okay, now what I've done here is flatten the store sales for shop. Okay. Now the engine will create a copy of all the cube, creating a new version, a version 3. Of course, this will take some minutes, because maybe not some minutes, but of course some seconds, because here our DB is something like, is the same you have in the demo, is about 2000 records, but as you can see, it will not take too much time. As you can see here, the version is changed. Now it's version 3, because I've saved a new version, and now I still work in version 3. And as you can see, the version is a dimension of the cube. So I can change version, but I can also use it as dimension, as dimension. Let me just take it. And so, in this way, I can make comparison between versions. So I create more than one scenario, and at the end, I can say, okay, I create this scenario, and I want to make assumption, I want to compare this version. Okay. Of course, if you want, you can also delete version. Okay. At the end of at the end, I can export my analysis in a file, a flat file, or in an external table. And now I can start the discussion with my boss or something in showing my new assumption. Okay, this is more or less all for this functionality. Let's take a look at the roadmap. Let me take the slide. Okay, good. As I've told you before, we'll have the calculated fields. We will have the calculated fields in the measure and dimension, and this is and we will have it in the next version, in 5.1. In 5.1, we will also have the export in XLS, so you can export what you are seeing in a XLS file. And we will have we will have two more algorithms, and all these things will be done for version 5.1. This functionality will be available later, and what is that? Actually, what we have seen today is part of the what-if analysis. The other parts are the definition of the scenario and the negotiation of the proposal, because the first thing you have to do is to decide, okay, I want to let the user modify only one measure, for instance. I want to create aliases, I want to create variables. All these things must be done writing the template of the document. There isn't a graphical tool that allows the user to create all this stuff, okay, all these things. And so this will be, we will do that for the later version, okay. So as you can see here, right in red, SpagoBI is open source solution. So we are very pleased to receive suggestions for the roadmap. And if you want, we are very happy also to receive contributions. So now keep in touch and still follow us. On Friday we will have another webinar about SpagoBI and big data. So if you're interested, please book your seat. Now, if you have any question or you're interested in something, just write in the chat, okay? Just write your question in the chat, and I'll be very pleased to answer you. Okay, good. No question. So everything is clear, everything is okay, and it's very good. So thank you for following us, and stay tuned. Bye-bye.